So what I want to do with this area model, I'm going to be doing exactly the same thing. I'm going to be on the same page as Mike. But my objective is I want them to make the connection. I want them to define the denominator, the part. I want them to define how many parts are in the whole and how many parts we're talking about. Mm-hmm. So define the numerator, define the denominator, find it in the area model, and see where the common denominator came in. See where, however many pieces they end up with is the common denominator.
Right. Robin's talking about how, within the area model, can the students define the denominators, right? So this fraction, how they define this denominator, how they define this denominator, so they can see the common denominator within the model.
Correct.
Okay. That's a lot of words. So how do we help clean that up so it's something more concise for students to understand?
Make connections to prior learning objectives of least common multiple and greatest common factor.
Okay. What do you think, Russell?
Kind of ties back in when we try to find common denominators. If kids know their multiplication facts, that helps a lot. So maybe if we can get that tie in, think of your multiplication tables and take these denominators and multiples of those. That might be one way to tie it back in.
So how do we streamline the language, in other words?
Yeah, I know,
so
that's the part I still struggle with. It's like,
yeah.
okay.
So we have that clarity.
Apply and
right.
extend previous understanding of common denominators.
Okay.
There you go. Yeah.
So, define success for today then. Right, so with this goal, if they're applying and extending their prior knowledge of common denominators to the area model using fractions, what does success look like for students?
Success, well, I'm going to have them using the area model suggested in the book. Then I want them to make a second one, but it's going to be create their own. They can create whatever area model makes sense to them. Success in one sentence.
Yes.
Draw an area model and explain the parts to me. I guess it's just that simple.
Okay, so we want to clarify our words, right, so that if a student were just to read what we're saying, it would make sense to them. I walk out the door today in Miss Walker's class, this is what I have to know. So, you said lots of bits and pieces, so maybe walking us through what it looks like, we might be able to come through the sentence.
Okay.
Right? So, you want them using that same fraction we had before, right?
Sure.
They were given this. What do you want them to do?
I want them to use the area model suggested in the math links and
Something like that.
correct.
Right?
Label, show me where the two fractions, show me where the 1/4 lies, show me where the 2/3 lie, and show me what the product is, where the product is in there.
Okay, so this piece of, right, they could do this. Right, and then do 2/3.
Right, and then for the product, tell me what the numerator is and what the denominator is, which will,
So how do we get to that part of from this piece?
that's what I want them to come to on their own. Okay, who can explain this area model to me? Who wants to come up and show us what this is all about? Chantel, do you want to try it?
Still trying to understand.
Okay, talk so we can hear.
I'm still trying to understand.
You're still trying to understand it? Okay, well let's ask me a question then. If you're trying to understand it, ask me a question.
Like, how do we do the area model?
How do we do the area model? Okay, can someone explain how to do an area model? Did you guys look back on page 2?
So, Monique, what did you talk about in your table group? What would be the reason for this dark color here?
It represents the fraction.
Okay, what fraction does it represent?
1/6.
Where is 1/6 coming from?
The
Explain the 1/6.
the dark purple represents the 1 and then the 6.
Okay. So, Michael, how could you explain 1/6 here?
Well, we're doing what we did in the homework. You label the top squares. Since there's 3, you do 1/3, 1/3, 1/3.
Mm-hmm.
And vertically, on the left side, you do 1/2 and 1/2.
Mm-hmm.
Since there's only one square, I can assume or infer that it's going to be 1/2 times 1/3.
Okay. And then this area would represent what?
The product. you
The
get,
product,
Which would be 1/6.
okay? So if I fill in 1/2 and I fill in 1/3, is this the area where they cross over?
Yes.
Okay.
Students, right? Because that gets us the piece of, okay, thinking of student work, what are we seeing from them gets us an eye into what they're thinking. So what else did we see?
I saw some, my students just ready to compute. They wanted to make the model after they already knew what the product was.
Right,
Yeah.
so that idea of the model match the answer. Right? I asked students, I don't know if anybody else did this, but I asked students, I said, do the amount of lines or boxes matter? And they said, no, as long as it matches, and they point to the answer. Right? Okay. What else?
And in my group, and I totally did not expect this, because I had mentioned in our preparation for this that I don't like putting the alternating lines because it just drives me crazy, gives me a headache. So I use the different colored bands. And thinking back now, what I should have done is introduced the bands separately because they had the different colors. And that first, basically the warm-up, where they had the two models, the coloring in and showing the overlapping in a third color, and then just coloring the squares that you need, which is the way MathLinks shows it. And what are you seeing here? And does it have the same fractional value? A lot of the kids said this was 11/16 or whatever the total was. And this is 11/16 and this is a different, or
Right, 'cause
six.
they counted all that were colored.
They paid no attention to the fact that there were different colors, and then there's this overlap.
Right.
And they're just, that's how many are colored in, and this is the amount here, and no, they're not the same amount.
11
And I'm like,
12s and 6 12s.
Yeah.
12s, yeah.
Yeah.
And I'm like, okay, that's very interesting. I was not expecting that. And that added a whole layer of confusion to them.
2/3 times 3/4. And so they did their lining fine. So they broke up the whole unit into thirds going one way and fourths going the other. But when it came to putting the values on the sides, it was 2/3, 2/3, 2/3 instead of 1/3 plus 1/3 plus 1/3 to make a whole, and 3/4, 3/4, 3/4, 3/4, because that's what they see. And it was like, ooh, that was interesting. I honestly was not expecting that at first, but then I started to think about, okay, knowing how literal our students can be, they'll see, as you put up there, 1/4 times 1/4 and 1/4 plus 1/4. They don't look at necessarily the operation, they're looking at that number and they get very, and that's what they focus on.
Right. The goal for the day, right? Everybody's objective was that students would be able to, right, take the idea of multiplying two fractions and model it correctly using the area model. Right? So in that piece, how do we then, when we designed our lesson, we have to go back and think about, the students can already do the math. What we're trying to get them to do is move away from, right, the know of the details of the math, right, and go step by step by step.
To understand the
To
concept.
understand what's happening in the math behind. So the question I'm going to ask is, in what we were doing and how we were designing our lessons, did we attack step or did we attack concept? in our instructional design. But if we ask the question to our students, conceptually, show me 1/4. Can our students do that?
I think so.
Problems all of them, probably.
Yeah.
Right? Pretty
Well,
close.
that's
They may do it a whole bunch of different ways,
Right.
Right.
but show me 1/4.
Yeah.
Conceptually. In the model, show me a fourth.
Yeah, most of them.
Right? And most of them are going to do something.
Yeah. That, yeah.
Okay? Here's where, then what do we do?
Yeah.
Right? Because
We
the
went to
next
the
step we all
the
did.
second fraction and went the other way.
That's what we all did.
That's what we
want.
did.
So we went to this.
Right. Well, okay, so we should have taken that piece and broken it up even that much further to make sure for the comprehension before we moved into the second fraction and showed them. That would have probably alleviated a lot of the, what the heck is this? Okay. I get it. I see what you're saying. You take it.
So-
one, okay.
If we use even a simpler model. Lunch combo from Little Caesars. How many pieces of pizza do you get?
I don't know. I don't eat it.
Good, nobody in the room knows. We eat it all the time because it's a quick, easy lunch roast. So, right? So the idea in this one would be half times a half. That was one of the problems on the page.
Yeah.
So, I say to the
This
students,
is the first one, actually.
I get half of the pizza. Model that for me. What will students do?
They'll either go vertical or horizontal, and they'll cut it the
Some way they'll cut the pie.
Right.
Right? So, I get half, and Dr. Martinez gets half. Right? If I separate it out a little bit.
Right.
Right? So, I get half, Dr. Martinez gets half. I'm not very hungry today, so I'm only going to eat half of my half. What would that look like?
They'll end up drawing a line across.
So, right? This is Mr. Daniels. Right? It's Dr. Martinez. Not fun. All the same letters in order. Play with that later.
That's actually, that's kind of freaky.
So, if I only eat half of my half, how do I model that?
They would, the kids would just draw a line right down the middle and take half and shade it.
Right?
So
And they
Mr.
would.
Daniels only ate this part. This
So,
part.
how much of the whole pizza did I eat?
Well, since a lot of my kids are food driven, like their teacher, they would probably know that they ate 1/4 of.
They might get a third if I don't make the connection here, right?
Right.
Because they'll do stuff like that. So we'd have to be able to make sure that we're getting all the pieces there. But a different line of questions towards the concept, right? Instead of towards the steps. Right? So the piece of what we're doing, right, is the whole goal of today was working towards building the concept and conceptual understanding of math our students already know how to do. And yet we taught it procedurally, and they already knew the procedure. And what did we see? We saw them trying to make their model match a procedure they already knew,
Procedure there.
which showed they had no conceptual understanding of what was going on in the math.